Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Al-Haziq. I'm from Group 17. I will present experiment heat exchanger for BMM 3531 Engineering Thermodynamic Lab. So for the introduction, heat exchanger are device that allow heat to be transferred between two fluids of different temperature while preventing them from mixing or coming into direct contact. So heat exchanger are different from mixing chamber in that heat exchanger do not enable the two fluids to mix. In theory, heat is transmit between the two fluids by convection and conduction via the wall that separates them. The magnitude of the temperature difference at that particular site will fluctuates along the heat exchanger, determine the rate of the heat transfer. So there are two types of flow arrangement, which is parallel flow. In a parallel flow setup, both the hot fluid and cold fluid are traveling in the same direction as each other. And the second type is counter flow. The hot and cold fluid enter the heat exchanger at opposites ends and flow in opposite direction. So objective of this study is to study the influence of volume and mass flow rates on heat exchanger performance. And second one is to analyze the most effective heat exchanger configuration, parallel or counter. So some literature review. The first stage determines whether or not the heat exchanger is operating properly, followed by a logical assessment to increase heat exchanger performance. And the second stage consider boosting pressure drop of available in exchangers with single phase heat transfer, and increased velocity results in higher heat transfer coefficients which may be enough to improve performance. And following that, the expected fouling factor should be carefully evaluated, and heat exchanger performance can be improved with regular cleaning and less conservative fouling factors. Finally, fin tube insert twisted tubes and redesigned batters may be used in specific case to optimize heat transfer. So this is the basic equation for co-current flow heat balance, counter current flow heat balance, and the general equation for heat transfer across the tube surface in a shell and tube heat exchanger.
Assalamualaikum warahmatullahi wabarakatuh. My name is Daniel Shafiq bin Muhammad Rashid, and I will continue the presentation for the heat exchanger lab. So my part is for the experimental procedure. So for the heating of, we begin with the heating of hot water. So the procedure is, the first one, check water level in tank and top up if necessary. Second, switch on master switch. Third, set the hot water temperature in the water tank to 60 degree Celsius. Next, switch on heater. Heating from an ambient temperature of 20 degrees Celsius to 60 degrees Celsius require approximation of 20 minutes. So the procedure is, the both valve were adjusted to set counter flow or open flow configuration. The central pump was switched on, and the hot water flow rate V1 to 4 liter per minute was set. Next, adjust the cold water flow rate, volume 2 to 4 liter per minute. Wait until the steady state thermal condition is established. Temperature changes from T3 and T4 are less than 1 degree Celsius per minute. So next, temperature T1 to T4 for both hot and cold water were measured. The sixth step is Repeat step 5 and to step 5 repeated by varying the cold water flow rate V2 to 6 liter per minute and 8 liter per minute. The experiment was repeated by adjusting the hot water rate V1 to 6 liter per minute. Next, the experiment was repeated by adjusting the hot water rate V1 to 8 liter per minute. The last one is the heater was switched off, centrifugal pump and cold water supply were after the experiment. I think that's all for my part. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Mahakim bin Nawawi, IDMA 19032. Today I will talk about the result, discussion, and also the conclusion of this lab. Okay, for the result, these are the counterflow data that we get from the lab sheet. And then we calculate for the LMTD, the P power emitted, power absorbed, and PNet efficiency, and then the U. These are the result that I get from the counterflow data. And for the parallel flow data, these are the result that I get. Okay, for the formula, log mean temperature difference, which is LMTD. I'm using a formula is THN minus by TC out minus by TH out minus TC in over ln TH in minus TC out over TH out over minus TC in. Okay, for the power emitted, which is PE, I'm using a flow rate, which is, in this case, we got 4, 6, and 8 times by CPH, which is constant, times by TH in minus TH out. And these are the example that I calculate using the formula. For the power absorbed, we use flow rate times by CPC, which is another constant, this times by TC in minus by TC out. And also, these are the example of the calculation by using the formula. After we get the power absorbed and power emitted, we calculate the efficiency by using the formula P absorbed over P emitted times by 100. And these are some of the example that we get is 106.75%. So for the U, which is the overall heat transfer coefficient, I'm using the formula P absorbed over area times by LMTD, and then we get the answer for the U. Okay, for the discussion, we can see these are the difference between the counterflow efficiency versus flow rate for the and parallel flow efficiency versus flow rate, which is counterflow efficiency versus flow rate is much more parallel to each other compared to parallel flow, which is kind of fluctuate. Okay, for the number 2 is counterflow heat transfer versus the flow rate. As you can see, both of the data for the counter and the parallel is quite similar. But for the counterflow, the 6 liter per minute is kind of lower a little bit compared to the 4 liter per minute. Okay, for the number 3 discussion is definition of coefficient of heat transmission. The term coefficient of heat transmission or heat transfer coefficient refers to the constant that link heat transfer to temperature change. It is used to estimate heat transmission through material or structure by conduction, convection, or radiation. The proportionally constant between heat flux and the thermodynamic force that propel the passage of heat is known as the heat transfer coefficient. W over K is the SI unit for this coefficient. Factor would affect the coefficient of heat transmission. Geometry is one of the elements that influence the coefficient of heat transmission. When the shape is modified, the heat transfer coefficient change as well. This coefficient is local quantity that is depend on the local heat transfer properties rather than surface area. The coefficient of heat transmission can also be affected by flow or velocity, as an increase in velocity can increase convection of heat transfer. Other elements that can affect a heat transmission coefficient are fluid temperature, material, and thermal boundary condition. Okay, for the discussion number 5, error that might influence experimental data and how to improve the accuracy of the experiment. Error that might influence the experimental data is insufficient heat insulation result in thermal loss to the environment. The second one is zero and sensor calibration mistake are example of sensor error. The last one is there is a leak in the heat exchanger tube. So how to improve the accuracy of the data is by calibrate the equipment before using to improve the data accuracy. Or the second one is by taking the average of the data, repeat the experiment numerous times to acquire the most dependable and accurate result. So the last one is to avoid falling and error in heat exchanger performance, as well as to improve the efficiency of the heat transfer process. We need to clean and maintain the pipes on a regular basis. Okay, for the conclusion, in conclusion, self-evident that a heat exchanger with a counterflow arrangement is more efficient than one with a parallel flow configuration. When the flow of one steam increases, the rate of heat transfer increase. According to the experiment, the amount of hot water loss is significantly in comparison to the hot water gain as a result of heat water loss in the environment. According to the computational, the log average temperature difference is more than the counter flow. In contrast to parallel flow, the overall coefficient of heat transmission for the counter flow is greater. That's all from us. Thank you.